Good evening, students. Please type in your questions. There seems to be no questions from the participants. Vivek, please unmute yourself.
Hello, sir.
I think nobody's asking questions, but I just wanted to share something which I'm teaching PDs currently in our institute.
Yes.
Started with heat equation this time. Because some books cover
Yes.
heat equation, Laplace wave, and then they come to
Yes.
if time permits. So doing heat equation, the main thing is that Cauchy problem in full space, right?
Yes.
One can prove existence under some conditions or the initial conditions, right? Like bounded continuous
Yeah.
function or the Tikhonov class.
Yeah. Yes.
And usually, solution to Cauchy problem is we just demand the smoothness that's required in the equation and for the initial condition. But this book of Helwig,
Yeah.
he incorporates this Tikhonov-like condition on the solution. Because finally he wants to say
Okay.
like this and
I
unique.
see.
So I
Yeah.
have, I have followed that Fridjon and Helwig. And also in deriving so-called this fundamental solution or the heat kernel, do
Yes.
uh, what is it called? Parabolic dilations or something.
Yes.
Usually for Laplace equation, no, we do this, that if
Yeah.
because it's rotational invariant, let us look for radial solutions. Okay, that's good idea. And then we end up with
Yes.
fundamental solution, we are happy. Heat equation, when we do that, x square by t or x
Yeah.
by t, we see. But, some factor will be outside. and we try a different kind of function. I mean,
yeah,
I did not, I find it again artificial slightly. I thought it is natural, but then people are not considering x square by t. They put one more factor outside, and finally they get fundamental solution. So the best way I find is that you
right.
uh, shamelessly do Fourier transformation, get the formula. Once
Yeah,
you get the formula, you try to justify under what conditions it gives the solution. I found that's the best option.
yeah,
Yeah.
yeah, I think so.
There is a question from Utkarsh. What information Jacobian gives in a PDE? Are you, I hope you are referring by Jacobian to the transversality condition. Am I right, Utkarsh? Please answer that. Otherwise, Jacobian in general, if you have a function mapping, some Rn to some Rn, same Rn, then Jacobian non-zero means local invertibility of the function. So that is just an analysis. And that's what we use in our analysis for the first order PDEs. Because we have xt variable is what we are interested in, or xy variables, but we get solution in terms of s and t. Now question is asked, can I invert? Can I express x and y as functions of s and t? Sorry, s and t as functions of x and y. So that's where this condition comes. It's better to call transversality condition. Utkarsh, anything else on the Jacobian you would like to know? Okay. See, we just look at the Cauchy problem that we are solving. Let's say quasi-linear equation, first order. Uh, we want to find a solution. That means a function of two variables. Equivalently, we want to find a surface, which is the graph of this function, z equal to u of xy. So we want to find that function. Now, we said that finding this can be done via characteristics. And characteristics have a parameter in them, which is t, which is running along the characteristic, each characteristic. But each of them is touching your initial curve at some s. So s and t are the variables, if you see. Characteristics, various families of characteristics you get. Now, if you can change st into xy, that's where the Jacobian condition comes. And if you can apply, if the transversality condition is satisfied, namely that Jacobian is non-zero, then you have a solution. If the Jacobian is zero, that is transversality condition fails, then you have several possibilities.
I think a few more people have joined, but they're not asking questions.
Please ask any question. Mhm. Okay, we'll wait another 5 minutes. There are no further questions. We will end the live session. Vivek, can you please answer?
Yes, sir. So there is one question in the chat box that whether questions in the final exam will come from the assignment or not.
Yeah.
The pattern of the final exam is similar to the pattern of the assignment in the sense that both are MCQ questions. So assignments as well as final exam are MCQ questions, and the pattern will be similar too. Uh, so questions of a similar nature will be asked in the final examination.
It's a computer-based exam, not pen and paper where you write the answers and all. So it will be exactly like our assignments, which are also computer-based, right?
Do you have any more questions about the pattern of the final examination, Jitendra?
So I think no further questions, it seems like. So we'll end the session now. Okay, then we will end this session. We'll meet in the next live session. Please have some questions to ask us. I'm sure you have questions, but you're not asking. You can do it on the forum, or you can do it on the Excel sheet, which is floated Google form for this live session. So it will give us some points that you're not getting it, and then we can discuss something in that. Otherwise, it will be again, some lecture kind of thing. It's of no use. Right? Yeah. Okay then. Thanks a lot. Thanks, Vivek. Bye.